Okay, last little video now, we're going to put it all together. So remember our equations from before. The frequency heard by when the source is moving is equal to the original frequency times the velocity of the sound wave over the velocity of the sound wave plus or minus the velocity of the source, and you use plus if it's moving away and minus if it's moving towards. That's for a moving source. And then we have f prime equals f times v plus or minus v observer over v for a moving observer. Notice it's flipped, and because of that, and it involves an observer velocity instead of a source velocity, and in this case we use plus when it's moving towards, and we use minus when it's moving away. Okay, and this is for a moving observer. Okay, so here's the situation. Let's see what's happening. Let's see if we could figure out which equations, which signs to use, and everything else. Let's say I have an ambulance. So here's a little ambulance. It has a little siren, and that siren's making sounds. And let's say that that ambulance has, when it's making the sound normally, the frequency sounds on a perfect A. So when V equals 0 for the ambulance, the frequency is 440 hertz. Now let's say the ambulance starts driving towards, there's a policeman over here who has things that she has to, it's going to help somebody, so it's moving over there. We have a velocity here that we don't know. Let's call it velocity of the source. We have the observer standing still, and we want to know what is the frequency. Let's say she hears the frequency at an elevated frequency of, let's say, 520 hertz. That's what she hears it at. So let's figure out how fast is this ambulance moving. There's a few other bits of information that we need. One is we need to know the velocity of sound, which we can assume is 343 meters per second unless otherwise told. So it's sound through air. So what equation do we use? Well, since we're given a source moving and we know the observer is stationary, we're going to use the moving source equation. So let's pull that down. We're given f prime, the altered frequency. We're given f, the original frequency. We know the velocity of the sound wave, and we want the velocity of the source. The question is, what sign do we use? And since the source is moving towards the observer, we're going to use the minus sign. So let's go. F prime equals f times v over v minus vs. So f prime is 520 hertz equals 440 hertz times v, which is 343 meters per second, divided by 343 meters per second minus v source. And now I just need to solve for this. So I do a whole bunch of algebra. I get I guess a little bit of algebra. 520 hertz times 343 minus Vs, if I cross multiply, equals 440 times 343. So let's do that. 440 times 343 divided by 520 is 200. Ooh, that's a really big, 290. Let's see. 343 minus velocity of the source equals 290 meters per second. And then that means that V source is going to be 343 meters per second minus 290 meters per second. So 343 minus 290 is 53 meters per second, which is like over 100 miles an hour. So this ambulance is flying. All right, that's it. Hope that's helpful. See you later. Bye.